Hey everyone. Okay, we are on to experiment 9, which is electrochemistry. Today we are going to make some batteries and we're going to do some galvanization or some plating, kind of my favorite thing. So some different things we're going to need for today. We need some copper salt, some zinc salt, some potassium nitrate solution, a series of beakers, some pieces of metal. We've got zinc electrodes here. We've also got copper electrodes. We're going to have a voltmeter because we're going to actually measure the voltage of the battery we're going to create. And then in a little bit, we'll talk about our galvanizing solution. So first thing for this lab is definitely kind of like your capstone lab for this class. It's the lab to see, did you learn anything and can you apply it? So first thing we need to do is, in the handout, it tells you guys to prep your own solutions. Obviously, I prepped them for you. You guys have to have an idea of what I did to be able to recreate it yourself because you will be writing this up like you had done it yourself. So this one's already dissolved up. I made a 0.1 molar copper solution in a volumetric flask. So I weighed out a specific amount of copper sulfate pentahydrate, which is what's in your manual. It's got your molar mass listed in there. I put it into the vol flask, I dissolved it and diluted it up to line. You've got to figure out, if I made a 50 ml solution of this, how much copper sulfate did I use in the first place to get to this volume? We also have a zinc flask of zinc here. You see the zinc solid in here? I have not dissolved this one yet, just because solids are a little bit different in a vol flask than a liquid. You did see us using a liquid vol flask in experiment 7, the kinetic lab, but liquid and liquid is a little easier. So solid. First thing you do is you use your wash bottle to rinse down the solid, any solid on the sides of your flask. Just twirling it around, swirling it around your hand, okay? Make sure you've got water in there. I've got it about, the bottle a little more than half full, and now I'm going to start swirling. You want to get all of this solid in here dissolved before you fill this volume up all the way. Remember, when you're making solutions, we talk about, like, 0.1 molar means 0.1 moles in 1 liter of solution. The solution includes your solid in there, includes the volume from your solid. So we can't just put enough salt into 50 mils of solution that, if we want that, it would actually be greater than 50 mils in total. So the molarity would actually be less than we thought it was, which is why we use vol flasks. We can put the exact salt we need in here, the exact mass we need in here, and dilute it up to a perfect volume, and that way we know it's actually the correct concentration. Once it's dissolved, it's all in solution, no solid left, we can go ahead and bring it up to line. Now that I'm close to the line, I need to actually see it. Okay, and we've got the zinc dissolved to line. To better mix these, I'm going to pour both of these solutions into their own respective beakers, so 0.1 molar zinc, 0.1 molar zinc. And 0.1 molar copper, 0.1 molar copper. Now, if you were actually in lab, you could do this next portion any way you wanted, but I'm going to go ahead and make all the solutions first and then measure the voltage, because it just makes my life easier. We will need our vol flasks again, so I'm going to go ahead and rinse it out. I need to make 2 serial dilutions from each solution. A serial dilution means, like, I'm starting with a 0.1 molar zinc solution, and then from that I'm going to prepare a 0.01 molar solution of zinc and then a 0.001 molar solution of zinc. Serial dilution meaning I'm taking the first solution to make the second, I'm taking the second solution to make the third. We do it as a serial dilution or a series because it helps truncate the air that we have involved in our system. I will be using a pipette. So you guys will have to do the math on it, but I will be using a specific amount of the 0.1 molar zinc and diluting it to 50 mils in our volumetric flask to get to the next molarity of zinc we have. So if I'm using a 0.1 molar zinc solution, I'm trying to prepare a 0.01 molar zinc solution, and I'm making 50 mils of my second solution. You guys should be able to figure out how much I actually used in the first place. How much I'm actually pipetting up. Again, good technique. Rinse your pipette first with your new solution. before you actually pipette up what you want. This pipette is a TC pipette, meaning to contain, meaning I do have to stop before the end of my solution. Anything left in my pipette should go to waste. Now it's liquid in here. I'm going to dissolve this up to, or dilute this up to 50 ml total solution. And pour that in my beaker that says 0.01 molar zinc. I need to do one more dilution because I also need a 0.001 molar zinc solution. Rinse my pipette. I'm not going to rinse the vol flask just because the solution I'm going to be using is the solution I just poured out of it. It's the solution I'm going to be diluting. So a little bit in there will be fine. Pull a little bit of this up. Throw it to waste. This is the 0.01 molar solution that I just prepared. Now pull up the volume I want. Again, I'm using a 0.01 molar solution, and I'm diluting it to 50 mils. So you guys should be able to calculate the concentration, or sorry, the volume I'm using. I'm using 0.01 molar. I'm creating a 0.001 molar solution, and I'm making 50 mils of it. So you guys should be able to tell me how much I just used. Dilute up to 50 mils. It would be a lot faster if I had a beaker to pour this, but I'm running out of beakers. And it's hard to pour into small volumetric flasks from a water bottle. Okay. Now I have my 0.001 molar solution of zinc also prepared. So I've got 3 zinc solutions prepared. I'm going to repeat this process with my copper. Got 0.1 molar copper solution that I'm going to dilute down to make a 0.01 molar copper solution. Got my pipette. Rinse my pipette. Again, I've got 0.1 molar, and I'm making 0.01 molar, and I'm making 50 mils of it. So you guys should be able to tell me how much volume I'm actually using here. Goes to waste. Dilute to 50 mils. Okay, that's my 0.1 molar copper solution. It's my pipette. And make my 0.001 molar solution. So again, I'm using a 0.1 molar solution. I'm using a certain volume, diluted up to 50 mils to make a 0.001 molar. So you should be able to tell me how much solution I'm using. This is going to go to waste. Into 50 mils. And dilute. And pour that into my beaker labeled 0.001 molar copper. Okay, now I've got all my solutions prepared. So the next thing I have to do is actually test my batteries. So we're going to start with the most concentrated solution, 0.1 molar zinc with 0.1 molar copper. We've got our two solutions here, and I will post photos of this in the video in the PowerPoint, but we've got the two solutions here, okay, zinc, copper, copper's blue. We've got a voltmeter. We've got our electrodes. We need all of this, but what we're missing is our salt bridge. The way we're going to make a salt bridge in this is we're actually going to take a piece of filter paper and chop it up into a strip. We soak that filter paper in potassium nitrate, and we just connect the two beakers with that solution. Or sorry, we connect the two beakers with that with the salt bridge. So, because it is soaked in potassium nitrate, I'm going to pick it up with your spatula, and I'm just going to set it across both beakers. I'm going to take your two electrodes, I'm going to place it inside their respective solutions, so copper and copper, zinc and zinc. You've got to make sure that the alligator clips that's connected to the voltmeter don't actually touch the solution, just the metal strips themselves do. And then we just read the potential off of the LabQuest. And I'm going to do this for all 6 of the solutions that you guys have to measure, and I will record that and I will send it your way. Hey guys, before we get into the next part of the experiment with the actual measurements, I want to explain how you guys should be answering your data sheets, okay? So your data sheet will look something like this on the first page. We might modify it slightly before we get to the final draft, but there should be 2 sheets to your data sheet, roughly, okay? The first part talks about the battery construction and measurements. How do we actually make these batteries and how do we actually measure them? And the first page asks you to describe and calculate how we prepared the 0.1 molar zinc solutions. Now, you guys weren't actually here to prepare them, I prepared them for you, but you still need to have an understanding of how it was done. So, I know I showed you in video, but so you can actually see what happened, I knew I needed a 0.1 molar zinc solution, okay? The salt I was using was zinc sulfate heptahydrate. The molar mass is in your lab manual. And so what I did was I went over the scale and I measured out exactly enough zinc to make a 50 ml solution, 0.1 molar concentration. With that information, with a 50 ml solution, 0.1 molar concentration, you should be able to tell me how much zinc I actually weighed out to make this solution, okay? That's what you need to describe in the first box where it says 0.1 molar zinc 2+. You need to put the calculations in there showing how much zinc I actually weighed out of the salt, and you need to specify that I use the salt for the first mixture. For the 0.1 molar mixture, I did use a salt, and you need to specify that. Do your calculations, show how many grams of zinc sulfate I actually used, and then describe in words how I then showed you guys on video. I added water to it, I swirled it to get it all to dissolve, and then I diluted it up to a total volume of 50 mils. That doesn't mean 50 mils of water plus my salt, it was total volume 50 mils. For the second one and the third one, the 0.01 molar zinc and the 0.001 molar zinc, I did serial dilutions. I took our 0.1 molar zinc, I took a specific volume of that and diluted that up to 50 mils to make my 0.01 molar zinc, knowing that I used a 0.1 molar zinc solution to start for concentration. Knowing that my final concentration was 0.01 molar, and knowing that I used 50 mils for my final volume, you should be able to back calculate to figure out how much volume did I actually use of the 0.1 molar zinc to make the 0.01 molar zinc solution. Okay? That's what it's asking for there. It's asking you to describe the dilution I did. You'll need to calculate, figure out what the volume of the 0.1 molar zinc I actually used to make the next down dilution, and then describe how I put that, pipetted up a specific amount, what that amount was, then delivered that to a volumetric flask and diluted that flask up to volume at 50 mils. For the last solution, the 0.001 molar zinc 2+ solution, I did the same thing, except this time I used the 0.01 molar solution to then make my 0.001 molar solution. Again, this is what we call a serial dilution. I'm using the most concentrated to make the first dilute solution, using that solution to make the next dilute solution. And if I was continuing on, I would do that all the way through. On the second page of your data sheet, it asks you to describe the same thing, but for copper. It's very similar to what I did for zinc. The only difference is that the copper is copper sulfate pentahydrate. I calculated ahead of time how much copper I needed to make a 0.1 molar copper sulfate solution, or copper 2+ solution. And then I did the same dilutions on copper that I did for zinc. So you guys should be able to calculate back knowing that I had a 0.1 molar copper solution that I diluted to make 0.01 molar copper and 50 mils. How much of that 0.1 molar copper did I use to begin with? Then the same thing for the last dilution. Okay, now that we've explained how to do the report sheet, the data sheet, the calculations, how we actually made the solutions, all of that, I'm going to go ahead and prepare the actual batteries, and we're going to measure the voltage of the different batteries that we have to test today. We do have 6 batteries. The first one, battery 1, is a 0.1 molar zinc solution and a 0.1 molar copper solution. You need to remember what is your anode, what is your cathode. Okay, that is very important for the for electrochem. Your anode gets hooked up to the negative terminal, and your cathode gets hooked up to the positive terminal. You've got negative and you've got positive on your voltmeter. The voltage itself will read out on the lab quest, and I will tell you guys what the voltage actually says. So we do have our 2 solutions, our 0.1 molar copper solution and our 0.1 molar zinc solution. We've got our anode and our cathode, our metal strips, okay? You can kind of see them here. And I'm going to place both of these into the solutions. I will show you guys pictures of this in the PowerPoint to make it show it a little bit better. The problem is, at this point, we have nothing connecting them. Before I put the metal strips in, I'm going to take a salt bridge. For your salt bridge, we have little pieces of filter paper that are soaked in potassium nitrate. So I just took a regular sheet of filter paper and chopped it up into a strip and then soaked it in a beaker. It's just a 0.1 molar potassium nitrate solution. It just helps the ions flow. And they do not want to separate. It's not toxic per se, but I don't really want to look. My hands are all over the counter. So again, all this does is help the electrons flow between the 2 solutions. So I'll show you a picture of it in an actual photograph, but I have the 2 beakers set up with a salt bridge just connecting the 2 solutions. Now all I do is place the corresponding metals into their own respective solutions. Copper and copper, zinc and zinc. The other thing you want to make sure of when you're testing with a voltmeter is the leads on the voltmeter, the little clips, don't actually touch the solution because they're made of a different metal. We want to make sure that we're only testing the solution we're actually interested in. Once we get it prepared, we read the potential off of our system. Let it settle. Looks like it's found its happy space at 1.09 volts. So again, that is the voltage. 1.09 volts is the voltage for the 0.1 molar zinc solution with the 0.1 molar copper solution battery. Take our electrodes out. We can rinse those off. Dry those off. The metal's perfectly fine. And the salt bridge goes to solid waste. Next, we're going to measure the next battery. The next battery we're interested in is a 0.01 molar zinc solution with 0.1 molar copper. So we've decreased the zinc concentration, but the copper stayed the same. We need to use a new salt bridge every time. They're not reusable, okay? When it goes into a different solution, it needs to have a new salt bridge. Put our electrodes into the solutions and let the voltage settle. For this one, I got a voltage of 1.05 volts. I'm going to repeat this process for the other batteries in this lab, and I will send you guys that actual data. For the last part of the experiment today, for the electrochem experiment, you're actually going to electroplate a piece of iron. So for yours, I'm going to actually get you data from an actual iron wire. Today I'm just going to use strips of iron and zinc. But we're going to use a little constant current system. It applies a specific current to our system that we can actually measure. We can measure the current passed. We can measure the time passed. We can calculate back to how much current did we actually pass compared to what the system says, etc. So it's kind of cool. You get to actually galvanize a nail. Wish you guys were here in person to do it because you could form your little wire into any shape you wanted and actually plate zinc on it. It's cooler than it sounds when you actually see it happen. But to do this, we've got a galvanizing solution here. And the solution would have been made by your TAs. Today it was made by me. It's just got zinc sulfate in it, it's got ammonium chloride in it, and ammonium citrate. Now the point is, what we're going to do is we're actually going to pull zinc from the solution out and plate it onto the iron wire. While that happens, zinc from the metal electrode itself will be pulled from the metal into solution. So the solution is completely regenerating itself all the time, meaning that this solution stays good. We can keep reusing it over and over and over because it keeps regenerating the concentration it needs of zinc in solution. To do this, we've got our two leads, we've got our zinc, we've got our iron. We just place it in solution, not touching each other, and making sure the leads are not touching as well. We turn on our constant current system, and we just hit play. Now, I'm going to let this run for 5 minutes, but I'm not going to make you sit here and watch it. I will show you guys a sped up video that I took with my phone to actually show what it looks like when it's actually plating on, because it's kind of cool to see it.